as I talked about earlier, the parameters beta 0, beta 1. And what we want to come up with is a way to estimate beta 0 and beta 1 using B0 and B1. Now, if what you want to think here is with these values, beta 0, beta 1 represent a large population, and what we typically will work with is a sample. So we're going to take a random sample, and so we're going to have ordered pairs. And we'll assume that in general we are collecting n ordered pairs. And guys, ultimately what we want to be able to do here is we want to have our collection of data. Let me make these a little and we want to be able to come up with the model which minimizes the sum of the distances from the point to the line. So we take the y values of each of these points, imagine being able to sum up all these distances, so we look at, more officially stated, the deviations from our y's to our predicted values. So guys, what we're going to examine here is we'll examine the difference between our y values and the predicted values. And guys, remember, we call this the error, and it's often referred to as the residual. A little bit of substitution here. Since we make our prediction by putting our x value into our model and multiplying and adding. But what we want to look at is we want to look not only of the deviations, we want to look at the sum of the deviations squared. So guys, ultimately what we're going to do is we're going to define a new variable here. I'm going to call this q. So we're going to sum from I equal 1 to n our y sub i's minus the predicted values. With the goal to find the minimum value of q, which kind of in reverse order creates beta 0, beta 1, which are estimates of, I'm sorry, B0, B1, which are estimates of beta 0, beta 1. Now, I want to start out here looking at a very, very, very simple small data set. So I don't know what we're going to use. Let's use the 0.11 no, let's do something else here. Let's go to, and let's go 3. So ultimately what we're looking for, you can imagine, there are infinitely many lines that we could draw through here, but we're looking for the one that minimizes the sum of the distances from our point to the line. Now, I'm going to just make an estimate here, and I'm just going to call this guess number 1. And I think it's kind of a reasonable guess. that if we have our data 1, 1, 3, how would things work if my model was just the horizontal line at y equal 2? Well, again, this point has a distance of -1. This has a -1, and this has a +1. So guys, for guess number 1, which is 2 plus 0x, my q would be equal to -1 squared plus -1 squared plus 1 squared, which is equal to 3. Now, is that the minimum value of q? Now, I don't know, but it's a guess. Now, someone may also say that, considering our data here, that, again, let's get that, I don't know, potentially align with, say, y-intercept equal to 1.5 and slope equal to, I don't know, let's say 0.25. Might also be reasonable, and it may even find a value of q that's less than what we had with y equal 2 plus 0x. So guys, what we could do, we can clearly create q. And remember, our q is kind of a difference between our y value and our predicted y. Well, guys, for the first order pair, our y value for, and again, what I'm doing here is for the first order pair 1, 1, our y value is equal to 1. Our predicted value is going to be putting x equal 1 in our model, which is 1.5 plus 0.25 times 1. I think that's what 0.25, 1.5, yeah. So my predicted y in this case is 1.75. So for the order pair 1, 1, the component of q for that particular point would be 1 minus 1.5 plus 0.25 times 1 quantity squared. Now, guys, clearly we can go ahead and do this for all the order pairs. So again, the first one is going to give me my y value minus the predicted value. Our second component of q is going to be my y value minus the predicted value. So guys, remember the x value for the second order pair is x equal 2. And the component for the third, actually the third point had a y value of 3 and an x value of 3. And of course, guys, we need to square each of these terms. Now, give me a second to plug these into calculators. So, guys, the first term we get 1 minus 1.75 quantity squared, plus second term we get 1 minus What is that? So 0.25, 50, so it's going to be 2 quantity squared. And we get 3 minus 0.75, so it'll be 2.25 quantity squared. So if my mental math is correct, we get, or at least I get, the way everything else has gone today, this is probably wrong, but I think I feel pretty confident with it. So, so our second guess, if we go back to this, guess number 1, we got Q equal 3. And for guess number 2, we get a better Q. Again, because what we're trying to do is minimize the value of Q. Now, guys, you know, guessing like this, guess number 1, guess number 2 is perfectly good for experimentation, inquiry, investigation. But what we want to do here is we want to create some theory. So let's do that. So again, going back to our original data set, we're at a point of 1, 1, 1, 2, 1, and 3, 3. Now, let's not create a line with a given slope, given intercept. But let's just look at a line in general. So what I want to do for starting this out is just examine what we have for this value right here. So guys, we would have our y value, which is equal to 1, minus our predicted value, which would be beta 0 plus beta 1, and I'm going to put times 1 even though it's redundant, quantity squared. Now, I don't know, you may need to pause. That may be just immediately clear. Some of my brighter 3,500 students last semester had a difficult time wrapping their mind around that at first. Of course, ultimately they got really good at it. So guys, anyway, in general, for the points, again, 1, 1, 2, 1, and 3, 3, we get a Q equal 1 minus beta 0 plus beta 1 quantity squared. Our second term, we get our y value, 1 minus beta 0 plus 2 beta 1, or 2b1. And our third term, we get our y value minus our predicted so I want to clean this up a little bit. So this is going to be equal to 1 minus b0 minus b1 quantity squared plus 1 minus b0 minus 2b1 squared. Hoping I can get all this in. 3 minus b0 minus 3b1 quantity squared. Alright guys, finding maximum minimum values, we need to take derivatives. So we put on our calculus thinking hat. So the first thing I want to do, since we have, we have two variables, so we're going to have to do the partials. So we're going to take a partial of q with respect to b0 first. And the first term, we're going to get 2 times 1 minus b0 minus b1 times using chain rule, the derivative of the inside part with respect to b0 gives us negative 1. The partial with respect to b of the second term gives us 1 minus b0 minus 2b1 times negative 1. And our third term, we have 3. Wow. We have 2. So 3 minus b0, 3b1 times negative 1. Make sure I didn't do anything silly here. All right, 2, negative b1, negative 3, 3b1, 3b. Okay. So guys, it's going to clean up to give us two. Negative 2 plus 2b0 plus 2b1 minus 2 plus 2b0 plus 4, right? 4b1 and minus 2 plus 2b0 plus 6b1. Alright guys, putting all this together, it looks like we're going to get negative 6 plus 6b0 plus 12b1. Now, because I've messed up earlier, I want to just double check here. So, and I screwed up, didn't I? It's one place I really like the board better because you can keep your work in front of you. And all right, so make sure I didn't do anything silly here. So minus 6 plus 2 plus 6 minus 6. Okay. So guys, this is our partial of Q with respect to B0. Now what I want to do is I want to look at the partial of Q with respect to B1. So let me go back and get an indication what we're going to happen here. So we've got 1, 2, 3 on our, so we're going to have 2 times 1 minus B0 minus B1 times negative 1 plus 2 times 1 minus B0 minus 2B1 times negative 2 plus 2 times 3 minus B0 minus 3b1 times negative 3. So see if we can clean this up here. So we're going to get negative 2 plus 2b0 plus 2b1. And we're going to get minus 4 plus 4b0 plus 6b1. And we're going to get is that minus 18? We got 6 minus 18 plus 6b0 plus 18b1. So guys, it looks like we've got negative 24 plus 12b0 24 so 18 20 plus 26 b1. So ultimately what we got, if we go back to again, this is the partial of q with respect to b1. So if we go back and take a look at we have what, negative 10 6 12. That's right. I don't want to put 6 and 12, yeah. And then of course we're going to set the partial that we just set these equal to 0. Hey guys, what I'm going to do is I'm going to just quickly put this in augmented matrix form. I'm going to use my calculator to get this solution. So using my TI 84, I'm going to go to matrix, and I'm going to store matrix A as a 2 by 3 matrix. So we have 6, 12, and 10. Then we have 12, 26, and 24. So go to matrix, go and apparently I've messed up again. Tanya, hand me that. Let's see what's going on here. Okay, that's right. Partial with respect to B1. Let's see, guys. I'm not giving up on this one. All right. Daggone it. Okay, so with respect to B1, we've got all right, so we've got -2 plus 2, -4. B. We've got -18. And please accept my apologies on this, but I've made a simple mental mistake. So the first we've got -24, and the next we've got 12, and the next we get 26. So make sure I put this in my calculator correctly. So 6, 12, 10, 12, 26, 24. I don't know what to do with my. Huh? I can't pause it. If I pause it, it'll kick out. Okay. Alright, so this looks good. So -6 plus 12, that one's solid. So now we go B1. So we got 2. So that's correct. And we got -2. So that's correct. And -2. Those are almost 31. That's correct. So we get -2 plus 2 plus 2b1 minus 4 plus 4 Oh, shoot. Okay, this should be an 8. This would have been the beauty if we were all together. I'm sure someone would have caught that. So we've got 9, 18, 6. Yep. 2 times 2 times 2 is not 6, is it? So, gosh. All right, so we're going to have 26, 28 here instead. Well, this has been fun. Actually, if it wasn't the 4th time I put this lecture up, I would have probably stopped and figured it out. All right, so let me change this in the calculator. And we finally get the right answer. So from our calculator, we end up with negative 1/3, positive 1, telling us that our model is has a y-intercept of negative 1/3 plus x. And our q value will be, again, y value minus, again, let me put this down here so I don't do anything really silly again. So we would have 4/3. And our other y value would be 1 minus 1/3 plus 2, which is 7/3, plus our y value of 3 minus 10/3. Guys, putting this in our calculator. Luckily, you guys are all teachers, so you understand these things happen from time to time. So we get a value of 2. So this is the minimum value of Q that we could get, which results in the best estimates of our parameter. So we're going to say that beta 0 equal to 1/3 is our best estimate of B0, and beta 1 equal to 1 is our best estimate with beta 1. Now, guys, as you may imagine, we're, if this is truly a random sample, then if we repeated this, we would have sampling variation, naturally. And we would certainly expect another value for B0 and B1 with another random sample. But we'll get into that soon enough. So, guys, let's kind of generalize some of the stuff that we've done so far. We've started out with Q, which is, I tell you what, let's just get this in summation. Let's going to be the sum from I equal 1 to n of our y sub i's minus theta 0 plus theta 1 x sub I quantity squared. Now, differentiating, we get the partial of q with respect to b0. And guys, let me be consistent here. Was not consistent. All right, so our partial of q with respect to b0 would be -2. The sum from I equal 1 to n of y sub I minus b0 minus b1 x sub I and partial with respect to q, partial q, I'm sorry, with respect to b1 is -2. Sum I equal 1 to n y sub I b0 b1 x sub I times x sub I. Okay, now if we set each one of those equal to 0, set the other one equal to 0. And tell you what, I'm going to move the x sub I in here. I don't know, is it clear? I just kind of took this for granted that everyone would know. Is it clear where the x sub I came in? You know, back here, if we're taking the partial with respect to b1, then the partial with respect to that would be negative x sub I. We can factor the negative out, but the x sub I varies, so it's not something that we can factor out. So it just becomes a term that we're kind of stuck with. All right, so taking this, we can clearly simplify, divide through by -2, which gives us the sum I equal 1 to n y sub I minus b0 minus b1 x sub I. And should have just played the power of the eraser here. All right, so let's think about those as So guys, we can clearly expand all this. I'm gonna leave the subscripts off. I think we're all okay with that. Okay, so this term right here, we're gonna have B0, B0, B0 n times, so it'll be negative n B0. And this term right here will have, let's see, B1, so B1, B1, B1 sum x. So we can write that as negative B1 sum x of I is equal to 0. And we can get the sum of the products. And then we're going to get the sum b sub zeros x of i's, so minus b0 sum x of i's minus, so this is going to give me minus b1 sum of x of I squared. I remember this now. Okay, now let's see. Now let's, I don't really know if we're ever going to need this, but I see something I'd like to be able to do here. I want to simplify this a little bit. I want to get my B0s. If you think about ultimately maybe using matrices. It's legal, isn't it? Yeah. And then yeah, I'm glad I did this. So I would have the sum of our x of i's b0 plus the, I'll tell you what, I'm going to mess this up a little bit. I don't like the way I wrote that. The point I'm trying to make here is so that should be plus b1 sum. And all right, so really what I want to do is just get these in terms of where I've got my my B0 terms, and I've got my B1 terms, like that. Now guys, what we call these, and get rid of this now. Yeah, this is exactly what I want. All right, guys, we call these our normal equations. And I gotta go back to my notes here because we can actually show that if we solve simultaneously, and it may be a homework problem. In fact, that's my plans right now. That we can get B1 is the sum the x sub i's minus x bar times the y sub r's minus y bar over sum of x sub i's minus x bars squared. That'd be 0. Actually turns out to be much easier to solve. Yeah. And I'll tell you what, let's just go ahead and clean this up. So if we distribute our sum of y, so this is just going to be y bar minus b1 times x bar. So let's keep these put these on the back burner, and we'll start out. Actually, I think I'm probably about out of time on this. See what my time looks like.